Okay, so today we will be starting chapter 6. We will also, with this chapter and this section, we will be starting um, to work on integration, the integration part of calculus, or the integral part of calculus. And what we're going to be doing for the remainder of our time studying calculus is we are going to look at reverse differentiation or antiderivatives. So the topic we start with is something called an antiderivative, and right here we have the definition of an antiderivative. So what is an antiderivative? Well, the antiderivative of a function would be the original function if you're looking at what the derivative of something is. So capital F of x is an antiderivative if when you take the derivative of it, you get the function in question that you're looking at. So for example, the best way to do this is just with an example. Find an antiderivative for f of x equals x squared. What's happening here is a similar question as I am telling you that y prime is x squared. That I took the derivative of something and I got x squared. What was the original guy whom I took the derivative of if the derivative was x squared? So I want you to think about that for a minute. I took the derivative of something and I got x squared. What should I have started with? Okay, well, if your derivative is x squared, then I know from the power rule that I should have had an x to the third to start with. Because when you have an x to the third and you do the power rule, then your derivative is 3x squared. But see how, so I get the right exponent that way. Because I must have minus 1 and gotten 2. So that means I started with 3. There's a problem with this, however, because the derivative of x to the third is not x squared. The derivative of x to the third is 3x squared. So how do I account for not having that 3? Well, I must have, when I multiplied by 3, because you multiply by 3 from the exponent of 3, I must have had a 1/3 in the front. Because if I had a 1/3 in the front, then the derivative would be 3 times 1/3 x squared, or 3/3 x squared, and those 3's cancel. And so we have a reverse power rule. A reverse power rule. The antiderivative of x to the n is x to the n plus 1, and it's 1 over n plus 1 in the front of that. And the reason for this is because note what happens if you take the derivative of this. You get n plus 1 over n plus 1 x to the n plus 1 minus 1, or x to the n. That's how that simplifies. So this is the power rule for antiderivatives. We have a power rule for antiderivatives. Okay, so I want to talk about one other strange thing that's happening here. So if I tell you that the derivative was x squared, you tell me, oh, well, then that must have been 1/3 x cubed who you took the derivative of. And that is true, and that is right, and that's called the antiderivative. That's what we just talked about. But also, there's another choice. Actually, there are infinitely many other choices for things who could have a derivative of x squared. Maybe y was 1/3 x to the third plus 7. Could this be our antiderivative? Why, yes, it could, because when you take the derivative of that, you get x squared plus 0, right? In fact, you get plus 0 anytime this number here is a constant. Anytime that number there is a constant, then the derivative of the constant is 0. So when you do an antiderivative, you typically put a plus c. And this is called your general antiderivative. And that accounts for the fact that you could have had it a plus 7 at the end or a minus 21. So we say plus C at the very end. All right, on the next page here, I have 5 functions. And what you're looking at are the derivative of somebody else. And you've learned derivatives. And so what you're doing in this question is you're to find the antiderivative. So you need to remember those derivative formulas backwards. This is the answer. This is the derivative of somebody. My question is, who is it the derivative of? So I would like for you to take the time and answer these 5 questions. I am going to go ahead and do number 5 for you, just to get us moving along. So I want you to remember that with radicals, you write those as fractional exponents. And what you're going to do here to do the antiderivative is you're going to use the reverse power rule. So for 3 is 3x to the 0. And so when you use that reverse power rule, you say 3x to the 1 over 1. A 0 plus 1 is 1. And then for x to the 3/5, you're going to do x to the 3/5 plus 1 and 1 over 3/5 plus 1 in the front. Okay, now we do want to clean this up a little bit. So this is 3x plus 3/5 plus 1 is 8/5. So this is x to the 8/5. That's what this number is down here on the bottom too. And 1 over 8/5, that's a reciprocal. So you just have 5/8. Also, I would like for you to remember to put in a plus C on all of these. So here's your answer for number 5. And you need to pause this and go and do 1 through 4. Now, just to make life a little bit confusing, we have 2 ways of writing antiderivatives. Well, I guess several ways, but the newest way and probably the most recognizable way is with what is called an indefinite integral or an integral sign. So this is just new notation, and what the new notation tells you to do is you have an integral of f of x, and then you have this dx back here. We are not going to discuss what dx is at this point. Later on, we will. Dx is significant, but for right now, you just need to ignore him. But this integral sign of f of x dx tells you to perform an antiderivative. It's an operation. It's telling you what to do. It's the calculus operation. Perform the antiderivative and tell me what that answer is. So the integral sign is that long skinny S, and it is an S, but it's very long and skinny, and S stands for sum, which seems strange, but that's what it is. The integrand is what you're doing the antiderivative of. It is the function inside. So in this notation, it is f of x. The variable of integration, you can think about the dx as telling you that. We're not going to do different variables, but in calculus 3, which is multivariable calculus, that is a very, very significant thing. So x is the variable of integration. Okay. So let me get back here for just 1 second. So in our new notation, if I tell you that y prime equals x squared, you will tell me that y is 1/3 x cubed plus b. Also, if f of x is x squared, then you will tell me capital F of x, which represents the antiderivative, is 1/3 x cubed plus b. And now with this integral notation, which is the one we really are going to use a lot, you're going to tell me that the integral of x squared is 1/3 x cubed plus c. And so here you can see I'm kind of working down a line down the page. All right, new topic sort of, initial value problems. In initial value problems, we're going to work out that plus c thing a little bit more. So in these types of problems, you're going to be given 2 things. 1 is the answer to a derivative. So look in this first example. I'm telling you that y prime is this. dy dx is 9x squared minus 4x plus 5. But you're also given a second thing, a point on the original curve. This is the initial value. That's why these are called initial value problems. You need to find the original curve. This initial value is used to solve for C. Okay, that's what it's used for. Okay, so your very first step is to do the antiderivative, though. So if they tell me that the derivative is 9x squared minus 4x plus 5, then I'm going to do an antiderivative. Remember, these are all power rule antiderivatives in this polynomial. I want to add one to my exponent. So my x squared turns into an x cubed, and I divide by that also. And then in my next term, my x to the 1 changes to an x to the 2, and I divide by that also. And in my last term, that 5 constant is a 5x to the 1, and you would divide by 1. Then we're going to remember plus c. That's especially important on initial value problems. Let's simplify this. So y is 3x to the third minus 2x squared plus 5x plus c. By the way, at this point, you can do a check to make sure you're right, because you're very good at doing derivatives. What are the derivatives of it? What's the derivative of this? Well, it's 9x squared minus 4x plus 5, because c is a constant, which is the question, so you're right. Okay. The last thing we're going to do here is we're going to use our initial value. Here's my initial value. So the initial value tells me that if x is negative 1, then y is 0. So I'm going to replace y with 0 and x with negative 1. And notice the only unknown left here is c. And so I can determine what c is. So 0 equals negative 3, minus 2, minus 5 plus c. So 0 is negative 10 plus c. And so c must have been 10. And so now my answer is, let's squeeze it in here, y equals 3x to the third minus 2x squared plus 5x plus 10. All right, now you have one to practice as well here. This is a nice polynomial, and I gave you an initial value. So go ahead and solve that on your own. Pause the movie and then come back. I'm going to do this last one for you. This is an initial value problem as well, but notice there are two tricky things here. Well, there's just one tricky thing here, really. This notation is for the second derivative. So the question is giving you the second derivative and asking you to find the original y. What does y equal? I know you guys like x, so I'm going to change this theta to an x. What is the original y? They've told me the second derivative. So if you know what the derivative is 2 times over, you're going to have to do the antiderivative 2 times over. So we're going to work this one step at a time. If my second derivative is cosine of x, I'm going to do an antiderivative. So if you anti-differentiate your second derivative, you get back to your first derivative. Okay, now this is going back to our trig. Do you remember whose derivative is cosine of x? It's sine of x. The derivative of sine of x is cosine of x. Now remember, I have plus c. And additionally, they've given me 2 initial values. One initial value is for the first derivative, so I'm going to use that now, because I'm going to find this c now with that first derivative. So I'm going to plug 0 in for x. So if x is 0, then y prime is 1. So I plug 1 in for y prime and 0 in for x. The sign of 0 is 0. So this tells me that c is 1. So now I know that my first derivative, y prime, is equal to sine of x plus 1. So step 1 is done. Now let's do an antiderivative again so I can get y, not y prime, y. I'm going to do an antiderivative again. Okay, whose derivative is sine of x? Now this is pretty tricky. It's not cosine of x. Do you remember why? What's the derivative of cosine of x? The derivative of cosine of x is negative sine of x because this starts with c. But I don't have a negative sine of x. So this must have been negative cosine of x to start with. Because if I negate negative cosine of x, I get back to positive sine of x. So my antiderivative of sine of x is negative cosine of x. The antiderivative of 1 is x. And then don't forget plus c. And so this is a new c. You could call it a different letter if you want, but I won't. Now I'm going to use the other point that they gave me. This point is about the original y. If x is 0, y is 3. So I'm going to replace x with 0 and y with 3. So 3 is negative cosine of 0 plus 0 plus c. What's the cosine of 0? It is 1. And so c is 4. So my final answer is y equals negative cosine of x plus 4. Okay, and so that is all that I have for this lesson. Don't forget to do your problems, and I'll see you tomorrow.